Problem 2 on 16 free response calculus test. And problem number 1 says speeding up or slowing down. So in order to know if a particle is speeding up or slowing down, V and A, which is velocity and acceleration, have the same sign to speed up. If they have the same sign, they speed up. If their sign, they slow down. You remember earlier in the year, I had someone come up front, and when their velocity was positive, they were moving right. And when my acceleration was positive, I shoved them to the right and I sped them up. And then when their velocity was positive, they're moving right, and my acceleration was negative, I shoved them to the left and slowed them down. So we got to check both velocity and acceleration. So in order to do that, we're going to use the calculator, and we're going to use this thing right here. And we're going to find the velocity. We're just sticking in for the function calculator, and we get 2.979, which is greater than 0. So that means the object's moving to the right. Then we must show the person that's grading this that we know the derivatives of velocity is right. Show them that you know that. And then we're going to do math, which is derivative for this velocity. So I hope you would plug this y sub 1 in your calculator for that thing. And you're going to hit math 8, and then the very last and put x squared. And when you do that, you get negative 1.164, which is less than 0. So the answer is the particle. You have to show these two numbers, greater than 0, one's less number. The particle is slowing down at t equals 4 because velocity is greater than 0 and acceleration is less than 0. So reasoning. Doesn't even say to give a reason, but I would recommend you put that in the answer anyway. Part says find all times from 0 to 3 when the particle changes direction. I just said a minute ago, when the velocity is greater than 0, it's going right. When the velocity is less than 0, the particle is moving left. And when the object equals 0, the particle is stopped. So what I need to do is find out when this particle stops. So I want to know when is v of t equal 0. So we got this y1 is in our calculator, and you want to graph it from 0 to 3 because it says 0 to 3 up there, and you are looking for where the object x-axis. So when you do that, you're going to get, you got to hit second calc 0, and when you get that, your t is going to be at 2.707. And you need to have that number in your answer. And then if you look at your graph, there's going to be above, below that. So when your number, you got this 2.707, you're looking at this on, you could look at it on the graph, and it goes something like that. So it goes positive here and negative over there on your graph. It's positive left, and then you should say the particle changes direction at e equals 2.707 because V, or you could say V of t, either one's okay, changes from positive to negative at t equals 2.707. And that's going to be your answer for part B. Part C, find the position of the particle at time t equals 0. Well, they give me one position right here, so they're saying x of 4 equals 2. And then they give me this velocity function, and we're supposed to know the velocity on the position. So we are looking for, we're looking for when time is 0 right there. So we are going to do the fundamental theorem of calculus. The fundamental theorem of calculus says the integral, and since we are using 0 here for t and 4 here from t, 0 to 4 of the velocity. Now you're going to use y1 because, again, remember we put y1 in the calculator for that. dt is going to equal position of 4 minus position of 0. So we're going to take, when you type that integral part into your calculator, because you get to use your calculator, you get 5.815 5.815027. That's going to equal x of 4, which we know is 2 from, because that's given up here. And then that's minus x of 0. So we would subtract that 2, and we get 3.815027 is equal to negative x of 0. And so x of 0, when you divide by negative 1, is going to equal approximately a negative 3.815. And that would be the answer for part C. And we have one more part to do here. The total distance. So you're supposed to know that total distance is equal to the integral from left to right, absolute velocity. The absolute value of velocity is the key here for total distance. So that's what we're looking for. So here's your A. There's your B from the formula I just wrote. So the total distance is going to equal the integral from 0 to 3 of the absolute value of v of t dt. And once again, your calculator comes in very handy, because we've already put y sub 1 equals that thing again in our calculator. And so we type it in, and inside here you put y sub 1. If you don't remember, you hit math, number, and I think it's number 1 is absolute value. But when you type that in, you get approximately 5.301. And that's our answer right there. So that is all of problem 2. So I will see you for problem